Greetings, ladies and gentlemen. Thank you for joining me. In today's presentation, we're looking at this topic from further mathematics. This is mapping and function. In today's lesson, we're looking at the concept of mapping and function. If you are coming across this channel for the first time, thank you for joining me. The returning viewers, I really appreciate you. This is further mathematics. Let's look at the concept of mapping and function. Okay, before we do that, a function is a relation between two sets. A function, a function is a relation between two sets. Let's say set A and B. What is a set? A set is a collection of well-defined objects. A set, this is point number one, a set is a collection of well-defined objects. It's a collection of well-defined objects or items, as the case may be. Objects or items. Collection of well-defined objects or items. Okay, let's say we have two sets. We have set A, then we have this A mapping to B, that's f of x, or let's say y, mapping to B. Let's say we have the element inside this set A as A, B, C, D. Then here R, S, T, U. The element in this set A are called domain. The element here are called what? We call it domain or input or pre-image or object. Okay? And this domain is associated with X. Then the element in this B are called the codomain. Or we call it image. We call it image or codomain, as the case may be. Okay, then the element in A is called pre-image. Okay, so this is function. Okay, we say a function is a relation between two sets A and B. The relationship between two sets A and B, whereby the element in set A are the domain or inputs, or we call it the X value or the pre-image. The element in this B are called the codomain or the image. Okay, let's look at what we call range. A range are the element in the codomain that have their pre-image. It means if we have, let's say, I have something like this. The A is mapping to R, B is mapping to S in this order. Okay? It means the range here are R, S, T, U. Range must have pre-image. But peradventure I have another element here that doesn't have pre-image. It means the codomain will be all the elements that are here, where the range are the element in the codomain that have the pre-image. So any element that is in the codomain that doesn't have pre-image, that element is not range, but codomain. So in other words, we can say that range are the subset of the codomain. Subset of the codomain. Range are what? Are the subset of the codomain. Very important. Okay? So for a function to be a mapping, it means every function is a mapping, but it's not every mapping that is a function. Very important. So let's look at the concept of mapping. Then we'll now look at the condition for a function to be a mapping. That's point number 3 now. Mapping is any rule that associates mapping is any rule that associate set of two sets. Mapping is any rule that associate two sets of an items together. Two set of an items together. Mapping is any rule that associate two set of an items together. Very important. Okay, we have different types of mapping. We have one-to-one mapping, onto mapping, constant mapping, identity mapping, and many onto mapping, and many more. Okay, a condition for a function to be a mapping. Condition for a function. Condition for a function to be a mapping. It means for a function to be a mapping, there are condition number one. Every element in the codomain must have a pre-image, must have image. Every element in the codomain, every element in the domain, let me write it. Every element in the domain must have a unique element in the core domain. In the core domain. That's condition number one. For a function to be a mapping, every element in the domain, every element here, like what we have on the board, every element here must have an image. Like the image of A is R, the image of B is S, the image of C is T, the image of D is. So this is a what? This is a function and this is a mapping as well. But it's not every mapping that is a function. Very important. So every element in the domain must have a unique element in the core domain for a function to be a mapping. Number two, very important, condition number two. Condition number two now, every element in the domain must not have more than one element in the codomain. That's condition B now. No element in the domain must have, no element in the domain, no element in the domain must have, element in the domain must not have two image. Element in the domain must not have two image in the code, must not have two images. No element in the domain must have, no element in the domain must, or we can say element in the domain must not have more than two elements in the, must not have two image. Element in the domain, element in the domain must not have two image, must not have two image. What are we saying? What we are saying is the element here, like, it's not possible for this A to be like this. If this is the case, A is having the image as R, A is having the image as S, meaning this is not a function, but this is a mapping. But this is not a function. It means no element or element in the domain must not have two image. Element here must not have two separate image. These are the two conditions for a function to be a mapping. In other words, every function is a mapping, but it's not every mapping that is a function. What are we saying? Let me still illustrate. Let's say we have a child here, then father. It's expected that every child must have a father. There's no how that you have a child and that child is having two fathers. It's not possible, biologically speaking. So let's say we have a set A, B, C, D here. Then we have another one as R, S, T, W here. Child A can only have one father. That's what we mean by function. Okay? Child B can have only one. Then even D, the same thing. This is a function. This is a function. It means, biologically speaking, only a child can have only a father, not two fathers. Okay. Another thing again, as far as mapping is concerned, let's say I have a power bank and my phone. Then I want to charge that phone. I have to use a cord. That cord is like what mapping is all about. Okay, the phone and the power bank have different function, but bringing the cord in between now serve as what we mean by mapping. Is any rule that associate two set of an items together. Like that cord, that US cord now will connect the phone and the power bank together. So that's the practical example of mapping. Okay, so as I was explaining function, as I said, this is a function and this is a mapping. Biologically speaking, no child can have two fathers. A child, a father to a child, a father to a child. That is what we mean by a function. And this is one-to-one mapping. This is a function and this is a mapping as well. In my next video, we'll look at how we can solve as many questions as I can under this concept of mapping and function. Thank you for watching. Please do share this to your learned colleagues and don't forget to subscribe to TJS Maths and Further Maths Adventures. Thank you for watching.